Hello class, today I'm going to show you how to do the fatigue calculation, but much more realistic data. Imagine you are designing a structure. It could be a building, it could be any like a axle, and we have cycling loads. Usually those cycling loads are not uniform and like a sine or cosine graphs. They're not really smooth and very organized like that. If you saw string gauge loads, for example, string gauge load attached to a window inside a building with some like a wind blowing over that window, it is going to have some fluctuations inside that data which they're not uniform. So we need to take care of that type of fatigue calculations. Okay, let's start with our model. Again, I'm going to use that simple flat surface with a hole to just show you how we do those calculations. Let's see. This is our previous geometry. Let me see. We have convergence. I don't want this convergence. Let's delete that one. I want to have like a uniform mesh. Let's clear all the generated data. Okay. So now data. And I want to have 50 megapascal of pressure applied there. Let's solve it. Because mesh was very coarse, it is going to be very fast. Yeah. So this is the stress and deformation. And we can see life, damage, safety factor, and the others. Okay. So let's see. Currently, the type of load we have is fully reversed. As you can see, it goes to 1, negative 1, 1, negative 1, negative. So it moves positive and negative. That is why we selected fully reversed here. Let me change this to 1. No correcting factors. Okay. As you open this option, we already used zero-based, fully reversed. We have another case here, history data. Let's see what is history data. If you click here for history data, it is going to ask you a file. And these 5 files are like a default file ANSYS presented for us. Let's open one of them. For example, first one, SAE bracket history. And be careful and check that file type. It's .dat. So whenever we had strain gauge data, you need to convert that data to this .dat type file. Let's open it. And we can see that we have like a very non-uniform fluctuating data here, and this range of data could be for 1 hour, for 1 minute, 1 day, 1 month, 1 year. We don't care. It is going to be for a period of time. And then let's see, we are going to select again stress life. Between the theories, Goodman is good. We are happy with it. The other thing we need to take care is finite life. Infinite life. What this means, currently is 10 power 9 blocks. Block is the whole data here inside this graph. So what ANSYS consider says, let's consider whatever you have inside this block as one block, and I'm going to repeat that one block many times, and later you can decide what is the number you consider as infinite life. If this one block is the data for 1 hour, ANSYS with this default number, it is going to repeat this loading up to this block of loading up to 10 power 9 times. If this geometry passed that 10 power 9 times, it is going to say you have infinite life. If it's less than 10 power 9, it is going to be finite life. So we can work with this and change the data. Okay, we don't want to use this data. Let's generate our own data. Let's open Excel. And before forgetting, I want to explain this scale factor here. Remember the pressure I selected? Pressure was 50 megapascal. And for fatigue calculation, it is going to play with that 50 megapascal pressure. So these diagrams here in this block is going to apply that 50. So if this is 500, for example, consider this is 500 and the bottom side is negative 1000. You can say, let's have, for example, 1 divided by 500, scale down this, and this is going to be 1. So 1 means that 50 megapascal. And this part, because it was negative 1000, divided by 500 is going to be 2. So positive 500 megapascal, negative 100 megapascal. So because it's twice. So this scaling is people use it to scale down or scale up and adjust it with the pressure we have. Because strain gauge or any experimental data they're coming, we don't know what is the relation between load or pressure we are applying with those fluctuations. So you need to adjust this scale factor with the data you have. Okay, let's start creating our own data. Equal rand to create random data. So this rand is going to generate a random data between 0 to 1. I want to have reversible, something like a reversible positive and negative 50 megapascal. So what I'm going to do, I'm going to multiply this by 2. So the random data is going to be between 0 and 2 instead of 0 and 1. Now I'm going to subtract 1. Now the range is going to be between negative 1 to 1. The initial rand was going to generate us between 0 and 1. I multiplied by 2 and subtracted 1. Now it is going to be between negative 1 and positive 1, which is kind of our purpose because we want to have reversible loading, but in a random fashion. Okay, I'm going to copy this for 100 points. Okay, because ANSYS needs a file with a .dat extension, so I'm going to copy this, open Notepad, paste it here, and save this as, let me go to the folder, ANSYS folder, change this file type to all files, and history data dot dat. Now ANSYS is going to save this file as a .dat file. Let's go back here and find our data. Desktop, where are you? Here, ANSYS number 7, and we can see our history data. I'm going to import, and this is our random history data generated. It should be from 1 to -1, as you can see here. And 1 is going to be 50 megapascal, -1, -50. So positive and negative direction, we are going to have that pressure. Okay. Let's solve it and see the stress, life. We have 3000 of what? 3000 of that block. We can, for the minimum life, we can repeat that load, this block of load, 3000 times for our geometry to start showing failure here. Let me check safety. Safety factor is 0. What it means, ANSYS tried to repeat that block of load 10 power 9 times. If it didn't reach that one, it is going to consider failure. So let's see fatigue sensitivity. Number 1 loading history is our current situation, which is going to have very small number of cycles. But as you can see here, the design life is very large number, 10 power 9. The block of load we have here could be, for example, for 1 month's data. For civil engineers, they attach their load gauge for the column they have, and they're waiting for people to walk inside their car park, and the load gauge, strain gauge, is going to read the data with some frequencies. And this is a simplified data we have for 1 month. So if you want to repeat this 1 month 10 power 9 times, which where is it? Which we specified here, it's so long time. So you may need to change this number. Currently it's gray, but you can clear the data here. Now you can change it to, for example, 2000 times, which is pretty good. Now let's solve it. If I check safety, now we are about 1.1 safety factor, which is acceptable. For some parts it's about 15, but we are okay with that one. Let's check the sensitivity. It is about this point. Let's decrease this one to 100, which means it is going to start from 1, our current position. Let's see how it is going to change. Okay, I can go to 0. Yep. So currently we have very low number of cycles for that one. If you want to increase to a very big number, if you want, you need to decrease that load about this percent, like a 37% of that load to be able to reach that 10 power 9 number of cycles. Okay, so we learn something here. If we have actual experimental data, we can import it as a block. Remember, this block is going to have a time frame, and you need to make a decision for yourself for that time frame how many cycles of that block you need. Is it 10 power 9 times, or it should be like a 1000 times if it's months or day? So you need to consider that, and then your calculation would be much more rational. Okay, good enough for this part. See you next time.